This video is brought to you by Sporlan, quality, integrity, and tradition. Well, I'm called on a walk-in cooler that's not working. It's like 50-something degrees in here right now. This guy says almost 60, 50, whatever. So coils are not iced up. Everything seems to be running down here. So let's head up to the roof and see what's going up there with the condensing unit. All right, this is my walk-in cooler right here. So we come up onto the roof. The unit is not running. Compressor's warm, but it's not like hot, like it's off on overload, really. Huh. All right, well, let me get some things opened up and we'll start checking voltages and trying to figure out what's going on here. All right, I spun the condenser fan motors. They spin, so they're not just like seized or anything. We come in here, I've got my meter right here. Over here so you can actually see it. There you go. All right, and let's go ahead and check voltage coming in. Yeah, coming into the contactor. We should have 3-phase 208 volts. Line 1 to 2, nothing. 2 to 3, nothing. 1 to 3, nothing. So we've got no voltage coming to this unit. Power runs over to a breaker panel over here. So let's go have a look and see what's going on over there. I've had a lot of bad experience with this breaker panel and it getting full of sand. Okay, so walk-in cooler is right here. It doesn't feel like it's tripped. Oh wait, no, it is tripped, dang it. Oh, that sucks. Let's turn it off. Let's go over here. We don't want to reset it yet. We want to check to see if anything's shorted to ground before we reset it. All right, hopefully nothing bad happened here. Got my meter set to tone on continuity, okay? And so we're just gonna go around and we're gonna tone everything out to ground to see if there's any potential shorts or any possible shorts to ground that would have caused a breaker to trip before we reset it. I'm gonna put some alligator clamps on this so I can do this one-handed. All right, so I'm gonna test. So I got an alligator clamp going to ground right here, and I'm testing that it's actually grounding out to the base of the condensing unit, and it is, okay? So now I should be able to just run along and hit everything and see if I get any tone. Nothing, okay? Check the pressure controls, nothing. I mean, there's not really much more that could have grounded out in here. We tested it right now. We spun the condenser fan blades. Let's go ahead and test to see if our compressor has tone or continuity across it. So, all right, this is a 3-phase compressor. I just pulled the wires real quick and we're going from one line to one line. So we're just looking to see if we have resistance across the windings of the compressor. This is a 3-phase, so they should all be equal. 1.8, I mean, seems pretty dang good. 1.8, I mean, everything seems fine there. I don't see any shorts. Don't see any issues where the wires seem to have rubbed out on anything. Everything seems fine there. All right, I'm gonna put this back together and then I guess we're gonna have to get ready to flip a breaker on and see what happens. All right, I mean, again, I spun the motors. I don't see any electrical issues there. They don't seem to have bad bearings the way that they're spinning and stopping. Don't really see any issues there. I don't see anywhere where wires have shorted. Nothing seems to be suspect here. Wires come in, go directly. I mean, I don't see anything here. I'm gonna put the cover back on. I did put service gauges on here. I need to purge them. Okay, and change the refrigerant over to 404. I'm gonna put the cap on right here. If at all possible, keep that on when you're trying to start these things because you never know what's gonna happen. All right, I'm gonna struggle with that and then we'll get over to the breaker panel. There we go, I just actually got it. Let's get this guy on. And there we go. I mean, everything's there. Let's go ahead and get an amp clamp on here. And that way we can measure current. There we go. Turn that guy on. Shoot. What if I put this guy into defrost so that way it doesn't start till I come back over here? I think that's a good idea. If you look at it, it looks like it stopped working at like 4 p.m. yesterday, if this time was correct. I don't know. All right, so theoretically it shouldn't start. And we can come over here. It's getting warm up here too, really warm. These breakers historically have a history of getting full of sand. See, it tripped right away. It didn't even turn on. The breaker's full of sand. Nope, it's not even resetting. Damn it. Sand. I gotta open this up. This sucks. So check this out. This thing's full of sand. Won't reset. There, now it reset. There's probably sand all stuck inside that thing. Shaking it out, and I'll pop it back in and hopefully it'll reset. All right, let's see. Yep, that's it right there. Okay, we'll come back over in a minute. And now we're gonna come over here. It's in defrost, and we're gonna test power to see if we have correct power. So look, it started for a split second until the defrost clock clicked it off, and both condenser fan motors started up. So what the heck is going on here? And I heard the compressor click on for a second too. All right, well, we're gonna measure voltage on this guy, because right now the defrost clock is interrupting coil voltage to the unit. So we should have 210 from 1 to 2, 209 from 2 to 3, and 208 from 1 to 3. So we've got voltage going to it. So this thing should turn on. All right, 1, 2, 3, please don't blow up. Woo. It's rough. 15 amps. That's pretty bad just on one leg. That's really bad actually. 16 amps. It's dropping. That's really high current though for that compressor. Let's get in here and test voltage going out of the contactor. 208, 207, 207, so voltage seems fine. Doesn't seem to be a voltage drop. I'm testing across. So we're good there. Head pressure's through the roof because it's under a heavy load. It's really hot outside too. 12 amps, so it's dropping. That was a rough start though. It's currently 107 in the shade and it's only 10:30 in the morning, so it's supposed to be 118 here today. So this is a 20 amp breaker. It's running, but what is going on here? What caused it to trip? Or is it just sand in the breaker? It could have just been sand in the breaker. God, I hate this place. We'll start testing condenser fan motors, see if they're overamping and stuff. The condenser fan motors are allowed to run 0.43, actually 0.49, and they're both running 0.43. So I don't see a problem with that. Let's put this one on there. Yeah, we're allowed to run 0.49, so they don't seem like a problem. Our sight glass is still flashing, but the system just turned on. We're kind of, expansion valves are wide open right now. Saturation temperature on the high side is 136 degrees. Low side is 22 degrees. That doesn't seem too scary. So what caused this problem? Just high startup? I mean, but the box temp shouldn't have been that high to cause the high current like we saw right now. We're gonna have to watch it satisfy and then restart a few times to see if we see anything funky. I mean, the compressor doesn't sound horrible. It doesn't sound the greatest, but it's running. Everything seems okay. Looks like the sight glass is just about to clear up. It's hard for you guys to see because of the sunlight. I mean, everything seems decent. I'm suspect of that contactor.
Using a thermal imaging camera, we can see a really high overheat situation indicated by the white color in the middle of that contactor. That is not normal. There's something wrong with that contactor.
So, I mean, I'm letting it run for a while longer, but I'm gonna go ahead and replace that contactor for sure because it's got that hot spot right in the middle and that's kind of weird. Little odd, so 208 volt contactor with lugs. I'm gonna go down to my van and pick one of those out right now. I got a contactor and actually got 2 condenser fan motors. I'm gonna go ahead and replace those 2. Both of them have slightly gone up in current as they've ran longer, and I just got a bad feeling. When we're out here in the desert, you gotta understand there's a lot of sand going around and it's just constantly causing problems. These condenser fan motors are almost changed yearly because of the abuse they take. This equipment too, another theory. Number one, the breaker was tripped. It was full of sand. The contactor's overheating on that middle terminal. I'm suspect of the condenser fan motors, but also it's currently 110 degrees in the shade. 109, 110, right? Coming into the condensing unit, it's only 11 a.m. In the next 3 hours, it's gonna get another 8 or 9 degrees, if not 10 degrees more, because on the roof and the sun bouncing off this, reflecting. We're already at 387 PSI. I wouldn't be surprised if this guy goes off on high pressure too, just in the heat of the day. And with that startup current that it was running, after it cools down and the pressures equalize out, you know, I don't know. It's hard to say what caused this problem. But everything's running at the moment. The box is coming down in temp significantly. So I'm gonna go ahead and shut it down now, and we're gonna change out that contactor and those condenser fan motors. Got the new contactor installed. The old one, when I pulled it out and looked at it physically, there's a bad spot inside of it. We'll autopsy it at the end. Pulling the condenser fan blades off, these long shanked Allen wrenches really help. I'm gonna get them swapped out. I'm using 9721s. They're not my favorite motors, but they're really easy to stock in your truck and they work pretty good. They're pretty versatile. So, but again, it's pretty much like a 1-year shelf life on these, like 2 years max, but 1 year is usually the sweet spot on these in this high ambient temps that I notice. You can also see condenser super clean. We just cleaned it, so that's good to go. All right, let's hope that nothing blows up. I got it turned off at the defrost clock again. Got both condenser fan motors and the contactor changed out. Running in the right direction, that's a good sign. Moving air. Current's at 15, 16, and kind of dropping. Okay, it's dropping down. All right, we're gonna let it run for a while. I'm gonna clean up my messes. It's insanely hot up here. Like, I'm dying right now. Let's see what my thermometer says. Drinking water like a fish. 116. So, and it's still gonna get hotter. Whew, boy, I'm gonna clean up. Actually, I'm gonna go downstairs and take a break first.
Now that this has been running for a while with the new contactor, see, you don't really see the temperature difference anymore. Even in, even out, pretty consistent. So that's a good contactor.
All right, I don't know what caused this breaker to trip, but I did my best to look at everything. I found that the contactor wasn't in the greatest shape. Let's see what the temperature is now. 112 at the moment, so it's kind of moving around. The contactor was in bad shape. I was not very confident about the condenser fan motors. I changed them both. The sight glass is clear. Pressures seem relatively decent. Don't really see anything else going on. I'm gonna recommend that they replace that circuit breaker that I had to shake the sand out of. That'll be an electrician's problem. And I'm just gonna watch the box come down in temp, but I gotta get off this roof because I can't even speak correctly. My words are my brain is all jelly brain right now. So it's gonna take a while because this thing's been down for a while, but it's running, it's cooling significantly. That's the true box temp right there, because those thermometers are registering 50 degrees, but it dropped instantly down to this temp and then it's dragging ass, and that just means that that's the internal temperature of all the food. So it's gonna take a while. I'm gonna take a lunch, but that's it for this one. We're gonna give the customer the keys. We're gonna tell him to get that breaker replaced, and yeah, just keep an eye on it. You look at the inside of this contactor, you can see the points and how corroded they are, like how built up they are, and then you can see where they actually make contact on the base section. That middle terminal, you can see that was probably the biggest problem right there, where it was meeting this guy right there. And it's just, in my opinion, sand. I mean, there's sand everywhere in this thing. You guys can still see it as I'm just working on everything. It's just such fine sand that's in there, and it's just causing high current. I mean, you know, because it gets stuck in there, creates a resistance. you know, and it just has a hard time. So these contactors are just pretty much throwaways.
I have to be hyper aware of the high temperature, the ambient temperatures outside. When it gets that hot, I start to get jelly brain, and jelly brain is not a good thing, right? That's what I mean by jelly brain is I start jumbling my words and I'm not like 100% thinking straight. Now, it's not like I'm completely incoherent. Like I know that I'm starting to feel the heat hit me and stuff. So it's like, okay, got to make sure you're taking a lot of breaks, okay? I say this all the time, but you know, if it can get too late too quick, right? Way too quick. So you got to make sure you're taking lots of breaks, cooling off. Your body temperature is not meant to work in that kind of heat. And I realize there's other places that it gets even hotter. And I'm just saying that once you get past 100 degrees, you really still, you know, need to start really paying attention. And it can even happen before 100 degrees, right? Everybody's different. It's nobody's better than anybody else. I mean, your body temperature is trying to self-regulate itself. Depending on the humidity outside and different things, it really starts to affect. Now, this particular location, they get a little bit more higher in the humidity, essentially. I think it was climbing into the 40% range, which I realize that, you know, there's going to be people saying that's nothing, right? But for us here in Southern California, when it's over 100 degrees and we hit 40% humidity, that's pretty high for us. We're not used to that, right? So our bodies aren't really acclimated to, you know, that amount of humidity. And again, I totally understand that, you know, in other places it can be insane. So just always take care of your body. Drink lots of fluids. Don't drink soda, okay? Soda's the stupidest thing to drink when it's hot outside. Really, I'm dead serious. It's the dumbest thing to do. Do not drink soda. No high sugar content stuff. I typically drink multiple waters, and then I might throw 1 or 2 Gatorades in for the entire day personally. That's what works for me. But I try to drink water like a fish, right? And I know that doesn't make sense, but that's just one of those silly phrases that I use. So we went to this unit. You have to know your equipment, know the environment, know the situation, right? So I know that this particular restaurant gets a lot of sand blowing. Sand is just a nightmare. I've made lots of videos showing the sand here, and I know there's a bunch of people out there that are going to say, why aren't you using totally enclosed contactors? Why aren't you using, you know, this particular thing, relays, different stuff? I have yet to find a cost-efficient replacement for a standard contactor like this. You got to understand, these contactors, you know, they cost the customer like anywhere from 40 to 60 bucks, okay? And if I was to sell them a totally enclosed relay, the relays that I've found either can't handle the current, or there is some, but they're stupid expensive, and it just doesn't, it's not justified for the customer. Of course, I give them the options, right? But it just, there's nothing out there that I've found that can replace a standard contactor, handle the duty cycle that we have, handle the inrush current, you know, handle the high temps. I just have yet to find something. If you guys have a solution for me, shoot me an email. I'll check it out, right? But I've gotten lots of people shooting me all kinds of different stuff saying, this is what you should be using, and they're just not cost effective, or the size is too big, or, you know, there's a lot of variables. You know, I can't carry a $2,000 contactor on my truck. I can't put those on all my employees' trucks. It just doesn't make economical sense for me, okay? And I have to be able to pick them up, right? These contactors in this unit, I can go get them. You know, I could just run to the supply house and pick them up. So it's just one of those things. But we found that the circuit breaker was full of sand, which is just horrible, right? I told him to get an electrician to change it. Seems like we have to change those every year too. We found that there was a high temperature situation in the middle terminal of that contactor, potentially causing a problem. And I was very suspect of the condenser fan motors. Now, I don't know what caused the breaker to trip. It was tripped when I got there. Okay, it didn't seem like it, but it was, and then it wouldn't reset. I don't know what caused that. That's why I took all this time and went through everything. And I still don't know if I solved the problem, okay? You know, who knows? It's one of those things where you just have to do your best. You have to look at everything, and you have to evaluate the system as best as possible within reason, right? I can't be up on that roof for 9 hours watching that system. It's just too hot. I can only do so much. So I changed the hot ticket items. I changed the contactor, which I could see with the thermal imaging camera. I changed the condenser fan motors, which, you know, they weren't bad. They were running. They were running under current, but I started to notice the longer they ran, the higher the current went, and I just know that we have a lot of failures with those condenser fan motors, so I changed them, okay? Customers okay with it. Of course, I discuss everything with them. Just got to use your brain. Try to be as efficient as possible, okay? Have a game plan when you go on the roof, especially when it's these high temperature situations. You really got to be on your A game. You can't go up there and be like, huh, and just stare and think and, you know, and just take your time. You got to be efficient. Every time I went downstairs, I took something with me. Every time I came back upstairs, I tried to be as efficient. What am I going to need next? How many parts am I going to need? Bring it up. You know, that kind of stuff, right? So always try to be efficient. I really appreciate you guys making it to the end of the video. Thank you so very much. Leave me some feedback down in the YouTube comments. Let me know what you think. If you're interested in supporting the channel, there's a couple different methods. The easiest way to do so is watch the videos from beginning to end. That's the easiest way. There's links for PayPal, Patreon, YouTube channel memberships in the show notes of the videos. Those are just ways to make monthly commitments to the channel. You can also support the channel by going to my website, HVACRvideos.com. We have hats and other merchandise available. That's a great way to do it. Lots of great merch on there. And last but not least, TrueTechTools.com. If you go to TrueTechTools.com, check out the tools they have. I buy a good majority of the tools that I personally use day to day from TrueTech Tools. And yes, I do buy my own tools. They are not gifted to me, okay? I don't take free tools from people usually. I have in the past, but it's just not my thing. I don't like it because I like to be honest and not have anything to owe to people, right? I like to be able to say what I truly feel about stuff. So if you see me using my tools in my videos and I don't tell you it was given to me, I paid for it, okay? But go to TrueTechTools.com. If you like what they have, if you find a tool that you want, I have an offer code, big picture, one word. If you use that offer code, you get an 8% discount on majority of the items on their website, and I get a small commission. Another great way to help support the channel. It doesn't cost you anything extra. So check it out, TrueTechTools.com. Again, thank you so very much. I really do appreciate you, and we will catch you on the next one.